All right, welcome to conversions. Continuation of what we did the other day. So the first thing I'm going to have you do is I'm going to have you grab out your sheet with the conversion tables on it. The one side had the stair step, and the other side has this table right here. So flip to that side so we can take a peek at that, because we're going to be using that side today. All right, yesterday we talked about how the prefixes in the metric system are huge and very important when trying to figure out what kind of conversion we're going to do. So, and remember, the metric system is so awesome because you're going from, 1 to multiples of 10. So you just slide the decimal point one way or the other, and it's real easy. You don't have to memorize anything. Super simple. So we take a look here. Yesterday we had 1 meter. I want to find out how many millimeters there are. Now remember from yesterday, if there's only one unit label, that means it's the base. All right, that's like the meter, liter, gram, etc. Now, if there's 2 letters, the first one is going to be the prefix, and the second one is going to be the base. So here we have millimeters. Now, looking at this, I want to convert 1 meter to millimeters. If we remember from yesterday, we start for where we're at. We have 1 meter, so we know we're at 1, and we're going to go to millis. So we go 1, 2, 3 spots on the stair step to the right. And therefore, the decimal point, which is going to be at right after the 1 here, you go 1, 2, 3. And any humps that we create that have no numbers, we have to put in 0. So there is 1,000 millimeters in 1 meter. Okay, no problem, simple. Now, we're going to try something a little bit different today, a different way of finding, converting units. And this time we're going to do it because we're going to be using the terms that are so big, like tetra and giga and mega, and just so big, huge numbers. And so these things are going to be so huge that it's going to be hard to kind of do the stair step. It's going to be just way too big. So if we take a look at your chart, here you've got, -1, -2, -3 at the exponent. So we take a look at our chart here. You have your prefixes, you have what the symbol it is, okay? And then we're going to focus on this last column right over here. And this is your exponential multiplier, and this is what we're going to do here. If you take a look, it's 10 to the something. So in deci is 10 to the -1. Centi is 10 to the -2. Milli is 10 to the -3, so forth and so on. Now, if we take a look at up here, these guys right here, with the tetra, giga, and mega, before we could just slide it along, just one decimal point over. Well, these are so huge that there's more than just one place value. So it's multiple. So if you take a look at tetra is 10 to the -12, right there. And we take a look at giga is only 10 to the -9. So if I was going to go from tetra to giga, it's going to be more than one movement of the decimal point. So we can't go by the stair step using this chart. So what we're going to do is this. The first thing we do in this new type of conversion, it's super easy, unbelievably easy. All you do is this. You take a look at that last column, and we write the number, the exponent number above there. We're going to forget about the 10 right now. We're just going to write that number. So if we take a look at all of these, milli is 10 to the -3. So we write 10 to the -3 right here. All right. Then what we're going to do is we're going to write for meters. Now, meters is the base. Well, if you take a look here, if deca is 10 to the 1 and deci is 10 to the -1, the base is going to be what? 10 to the, you got it, 10 to the 0. So what we're going to do is you put a big old 0 here. So now we've got these two numbers above the unit labels. The next thing we're going to do is we're going to find the difference between the two. So the difference between 0 and 3, if you take a look over here, we got a little number line here, there's 1, 2, 3 spots difference, right? So we put a big old 3 in the middle. Now what we're going to do is we're going to circle this number because that's the number right there. That number represents how many places we're going to move the decimal point. So we're going to move the decimal point 3 places. But now we're like, okay, what direction are we going to go? Well, that's what we're going to find out right now. So what happens is we're going to take a look at, and we're always going to go towards the smallest guy. It's like Rocky, all right? You know those Rocky Balboa movies? You know, no matter what, you watch those movies, and who do you end up cheering for mostly? Yeah, you're cheering for Rocky, you know, because he's always the underdog. So we're going to always cheer for the underdog. We're always going to go to the side of the underdog. We're going to stick in his corner. So we got to figure out, okay, which number is smaller? Is 0 smaller or the -3 the smaller number? Well, -3 is the smaller number. So we're going to go, and we're going to go to that side. All right, so we're going to go in the direction. So now what's going to happen is we're going to move the decimal point 3 spots to the right. So let's do it here. So we take the decimal point. Now if you take a look here, there's no decimal point. Well, if there's numbers there and no decimal points, it can be seen on the number. Where is it assumed to be? At the end of the number. So we take a look here, a little dot here represents them. So we go 1, 2, 3 to the right. We put our zeros in for the humps that have no numbers. So then our answer is 1,000. Well, if we take a look here, we got 1,000 right here, and we have 1,000 right here. It's the same exact answer. All right, so let's take a look and try another one here. So now these are simple. We'll get to more difficult ones a little bit later. So we have 2.5 centigrams equaling how many DAG? So that's decagrams. So we take a look at your chart. The chart for centi is -2. So right, -2 here. On the chart for deca is what? Deca is a 10 to the 1. So now we're going to find out what is the difference between -2 and 1. Now, some people will say, oh, there's only a difference of 1. No, 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 no. Remember, take a look at the number line. We want to go from -2 right here to 1 right here. So we got to go 1, 2, 3 spots. So we're actually moving 3 spots over. So we're moving the decimal point 3 spots. Now where are we going to go? Are we going to go to the right or are we going to the left? So what do? Who do we support? Always support the underdog. That's right. So we're going to go here to the left. 3 spots. Take the decimal point. Go 1, 2, 3. Oops, ran out of room there. And so our answer is going to be 0.0025 decagrams. All right. Taking a look. Oops. All right. Taking a look at the next one here. Oh, full screen. I'm still working through this, so help me, work with me here. All right, so now we have 1 mg. Now, usually m represents milli, but a lot of times here in science, you're going to have, if it's capital or if it's lowercase, it makes a big difference. You got to be really aware of what kind of letters are we dealing with. So a big M is going to mean mega, all right, mega. And a little m means milli. So here we're having a megagram. So 1 megagram equals how many kilograms? So you take a look at our chart. We go, so mega. We take a look over here, and we go all the way across to the far right-hand side here. So we got mega here, and then we go mega here. And if we take a look at the exponent, that's 10 to the 6. So we write a 6 here. We take a look at kilo. Kilo's right here. That's a minus or a positive 3, so we put a 3 here above the unit label for kilograms. What's the difference between 6 and 3? It's a difference of 3. We circle it, and now we're going to go, we have to find, okay, what direction are we going to move the decimal point? It's going to go, who do we support? That's right, Rocky Balboa, moving to the low man. So we're going to support the underdog. We always support the underdog. So we're going to go to the right, because 3 is smaller than 6. Take a look here. We're going to go and move it 3 spots. So we're going to go 1, move it, put in the decimal point after the number. 1, 2, 3, fill in the zeros. So the answer is there are 1,000 kilograms in 1 megagram. All right, try another one here. So now, this time, we have 1.23 capital G's. That's not grams, remember that's a prefix, so it's going to be giga. And there we go. So now we're going to take a look now. Giga is right here, and that has an exponent of 10 to the 9th. So you write a 9 here above the unit label. Tetra is a capital T, and tetra has a number of 12. So now what we got to do is, that's right, support the underdog. So, well, first, before we support the underdog, got ahead of myself, pardon. Difference is 9 minus 12 here. We have a difference of 3. We circle it because that's how many decimal places we're going to move. Now we're going to move it to the, now we support the underdog. And so we're going to go to the low number, which is 9. Moving off to the 9. So we're going to take 1.23. We're going to move it 1, 2, 3 to the left. Fill in the 0. So our answer is 0.0, 0, 1, 2, 3. All right. So now here we have this. Now, if you take a look here, this symbol means micro. All right, it's kind of like a cursive U. So this is micro. So we have 1 microgram equals how many milligrams? Well, now we're going to take a look at micro. And micro is a -6. And milligrams is a -3. So what's the difference between -6 and -3? Difference is, of course, this happens to be 3. We're using a lot of 3s today, but it can be anything. If we want to use different examples. So we have 3 here. Who do we go? We support? We support the underdog. So we're going to go to the now. Now we have to decide. Now, a lot of people, well, we got to, which one's smaller? Well, usually 6 is bigger than 3. But if we take a look here on the number line, it's kind of like when you deal with negative numbers, it's like temperature. What's colder? -20, -10. -20 is much colder. So the bigger the negative number, the smaller it is. I know it's crazy, but it is what it is. So we take a look at the number line here. So here's -3, and that's much smaller than -1. So who do we support? We're going to support the underdog, which is, in this case, -6. So we're going to take 1 here and move it 1, 2, 3 to the right. Fill in the zeros. So 1 microgram equals 0.001 milligrams. All right, here we go. One last example here, and we'll turn you loose. So you have 0.41, just in time for the bell. 0.41 attoseconds, and then we have equals how many milliseconds? So we take a look here, and the prefix has a -18. So -18, huge number now. All right.
Following students come down to the office.
And we will stop it because it's getting crazy here. All right, so much for that.
Jeff Barstead, Ronnie Vang.
It's almost like it's real class, isn't it?
Mullen, Ashley Heil, Cole Bartz, Doug Hamilton.
Millie is -3.
Thibodeau, come down to the office.
What's the difference?
Gabby Olson.
Well, now we
Catherine
have
Whelan,
2 negatives, so it's
Emily Monroe, Haley
15.
Viner, Ronnie Vang, Jeff Barstead.
So now we go.
Megan Shoemaker, Natalie Mullen, Ashley Heil, Cole Bartz, Doug Hamilton,
So we're moving
Alex Langer,
15 spots. So now we're going to go, who are we going to support? Which is smaller, -18 or -3? Well, -18 is. We're going to go to the left. So we have 0.41, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, I ran out of room. So we're going to put all these zeros in. And that's your answer. A really, 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 really small number. So that concludes today's lesson. If you guys have questions, come on in bright and early in the morning. And stop.